Good morning, grade 10s. Today I want to go over solution concentration calculation. This is remote video lesson number 1. Now, the amount in a solution is measured as a concentration. And by definition, concentration is also known as the molarity. And you can hear that I'm saying molarity because there is a relationship between concentration and the number of moles of a substance in the solvent, dissolved in the solvent. So concentration is the measure of amount, which is mole of solute that is dissolved in a given volume of a liquid, the solvent. The equation symbol for concentration is a C. N is N divided by V. So concentration is mole per cubic decimeter. Concentration is the unit we use is the mole per cubic decimeter. So that comes from N being measured in mole, and volume must be in cubic decimeter. You can't use cubic centimeters or cubic meters to calculate concentration the way we do. A standard solution, the definition of a standard solution, it is a solution of which the exact concentration is known. Right, our examples, let's go into examples immediately. I want to calculate the concentration of a solution if 3.5 grams of sodium hydroxide is dissolved in 2.5 cubic decimeters of water. So we have the mass of the sample and we have the volume of the solution. And to calculate concentration, we need moles and volume. Now, if we don't have the moles, we can calculate the moles from mass over molar mass. We could do this calculation in 2 separate steps, or we could combine the 2 equations. Put the m over m in the place of the mole, and this equation becomes mass over molar mass for moles times volume. I'll do both ways. For moles, we need molar mass, and for molar mass, we need the formula of sodium hydroxide, NaOH. So the molar mass would be 23 for sodium plus 16 for oxygen plus 1 for hydrogen. That makes it 40 grams per mole. So the mole is 3.5 divided by 40. Which gives us a 0.0875 mole. Now we can go to concentration because it's a 0.0875 divided by the volume is 2.5 cubic decimeter. That's the correct unit, 2.5, and we get 0.035 mole per cubic decimeter. The other path we can take is with the combined equation here, and that would give us the direct answer. So it's 3.5 divided by 40 for the molar mass of sodium hydroxide times 2.5, and that you'll see gives us 0.035 mole per cubic decimeter. Right. Like I said in the previous videos, pause if you need to more time, but I need to continue with the next example. Right, the next example says you have a 1 cubic decimeter container in which to prepare a solution of potassium permanganate. What mass of potassium permanganate is needed to make a solution with a concentration of 0.2 mole per cubic decimeter? So they give us the volume of the solution, they give us the concentration of the solution, and they're asking us for the mass of the solution. To do this, I need to know the formula for potassium permanganate. It is KMnO4. The molar mass for potassium permanganate, it's 39 for potassium and 55 for manganese, and 4 times 16 for oxygen. It's 39 plus 55 plus 4 times 16 gives us 158 grams per mole. The concentration is the mass over molar mass times volume. Concentration was given 0.2. The mass is what must be calculated. The molar mass is 158 and the volume is 1. So the mass would be 0.2 times 158, which gives me 31.6 grams. Righto, number 3. Number 3 asks us, how much sodium chloride will be needed to prepare 500 cubic centimeters of a solution with a concentration of 0.01 mole per cubic decimeter? I'll do this one in 2 different steps. I'll first calculate the concentration mole over volume. We've got the concentration 0.01. The moles we don't have. The volume is 500 cubic centimeters, which we need to turn into cubic decimeters by dividing by 1,000. So we have to divide by 1,000, so it's 0.5 mole per cubic decimeter. Sorry. So the moles would be 0.5 times 0.01, and that is 0.005 mole. To get the mass of sodium chloride, we need to use this equation. Mass is moles times molar mass. We've got the moles, 0.005. The molar mass for sodium chloride is 23 for sodium plus 35.5 for chlorine, makes it 58.5, which gives us a mass of 0.2925 grams. Right, next example is on page 288 in your textbook. They say calculate the concentration of a solution that contains 0.2 moles of copper sulfate. It's 0.2 mole of copper sulfate. That's the N. And the volume must be 250 cubic centimeters. So they want us to calculate the concentration here. For that, we need to convert the cubic centimeters to cubic decimeters by dividing by 1,000. So that is 0.25 cubic decimeter. Concentration would be mole. divided by volume. So 0.2 divided by 0.25, which gives us 0.8 mole per cubic decimeter. Right, this ends the lesson on concentration. We will work on more stoichiometry in the next lesson.